Hi, everyone. Our project is called Microgravity Wine, and I'm Paige DeAndrea, and this is my partner, Max Holden. And we're from Chaminade College Preparatory, and our sponsor was Medtronic.
First, we were given this assignment in the beginning of the year to make an experiment, and we went through our book and found the fermentation, and we decided that the most optimal way to ferment something in space would be the fermentation of grape juice. And how that works is the yeast reacts with the sugar in the grape juice, and it breaks down the sugar, and it releases carbon dioxide and creates ethyl alcohol. And the formalin is used to stop the chemical reaction, so we can have both experiments fermenting the same amount of time.
So our experiment description is the main volume of the experiment is filled with grape juice. One small glass vial is filled with yeast and will be broken first to react with the grape juice. It will ferment for 5 days before stopped. And the other small vial is filled with formalin and will be broken second to react to the grape juice. First, in order to decide the ratio of wine to grape juice in a fermentation process, we looked up many different wine recipes and found the average ratio of grape juice to yeast. In the main volume, we used 3.3 milliliters of grape juice and 0.075 grams of yeast and 0.5 formalin.
After we knew our amounts, in order to get the amounts, we had to run it numerous times because the carbon dioxide levels would constantly pop up the top because there was too much pressure. So we ran it many times in order to find an amount that wouldn't pop off the top, and once we found it, we got our exact amounts, and we created our timeline of 5 days by running 4 or 5 different experiments.
Okay, so testing the carbon dioxide levels. In order to test it, we used a titration kit, and this is part of it. A titration kit measures the amount of dissolved carbon dioxide when something ferments. The gas is constantly being given off, which is why the experiment with more of the gas in it fermented more. We tested both to decide which one had the higher titration number.
After we figured out we were going to use the titration method, we found many different titration ways. There was another titration kit that we could use. However, this one didn't work with the red grape juice because it turns a pinkish color. And when it turned the pinkish color, since the grape juice was already red, it wouldn't work. So we decided that we were going to use the testing of the ethyl alcohol levels because as something ferments, ethyl alcohol is given off, and the one that has more ethyl alcohol is the one that has fermented more.
Okay, so the 2 experiments that were run on the ground are having their ethyl alcohol levels tested, one after 6 hours of fermentation and one after 5 days. This should help us for our next experiment in order to get a better idea of the ideal time frame. We also are testing the sediment weight in order to see if that would be an ideal way to measure the amounts without expensive machinery or chemicals.
The space samples we haven't gotten yet, but they were broken prematurely. So we made another experiment, and we broke it after 6 hours, the same as the one on the space station. And when they come back, when the one from the space station comes back, we'll test the ethyl alcohol levels of both of them. And the one with the higher ethyl alcohol, which we will predict is the space sample, is the one that fermented faster.
Okay, in order for our next mission to work smoother, we will be using white grape juice instead. The white grape juice will make the experiment testable by the titration kit.
We will also be adjusting the timeline to find the optimal length of fermentation based off what we learned in this experiment in order to see if we should use 5 days or possibly less time. Other than these things, the basic concept of the experiment will remain the same.
And we want to thank Ms. McIntyre, Susan McConnell, Medtronic, Chaminade College Preparatory, both of our families, and the rest of Chaminade faculty, and SpaceX, NCESSC.
The Chaminade experiment, as you've heard, is a flight experiment, Mission 1 to the International Space Station. Are there any questions?
What made you guys think the fermentation in space would be faster than on Earth?
Because in microgravity, it's in a constant free fall. It's going, as he said, 5 miles in a second. So it's constantly moving extremely fast, and speed usually speeds up other chemical reactions. So we think it'll speed up the fermentation.
Hi, I was just wondering, like, what's the purpose? What's the reason for us to be fermenting wine in space?
Well,
Well, the purpose is it'll be a lot faster. So instead of fermenting, like, because it takes like a year or two to ferment like wine, maybe even longer, it'll ferment faster, and it'll not only like things like soy sauce and like yogurt and vaccines. They also ferment, so it'll help like other things, not just wine.
So why did you guys choose to ferment wine other than other things like, yogurt or
this was much easier to test. It's just yeast and grape juice. Other things, a lot more materials, a lot more machinery.
And we only have
Yeah, we have a small vial, but there's vaccines, there's medications, a lot of other things ferment. If those things can ferment faster, possibly made stronger, it can help the medical field and other things.
All right, thank you.
Why did you decide to use the purple grape juice, and do you anticipate there being differences with the white grape juice in the next experiment?
Well, we didn't really plan on the purple grape juice. We didn't really plan on the color needing to be pink, so we didn't know that the purple grape juice would affect it, which is why we're going to use the white one for next time, so we can see the color change and we'll know how much fermentation took place.
All right, thank you very much.